Okay, folks, welcome back. We got lesson 8.1.4 here. Regular polygon angle connections is the title of this lesson. Let's remember what this means. A regular polygon has all sides congruent and all angles congruent. In the last lesson, we covered some formulas about the angles in a regular polygon. I just kind of want to review those quickly here. I'm going to draw a part of a regular polygon. Let's say I'm just I see two sides of it. And then let's say the rest of it's cut off. I can't see the rest of it. If I call this angle B right in here, the interior angle of that polygon, and then I extend this side out this way, and I call this A, I see that I have an interior angle B and exterior angle A. And we saw some formulas with respect to these two angles. I'm going to repeat a couple of those for you here. First, we know the sum of the interior angles is equal to 180 times n minus 2. That's actually from lesson 8.1.2. And if I have a regular polygon and all the angles are the same, for all the interior angles are the same, then the measure of one interior angle the sum of the exterior angles, let's go to blue now since we're talking about exterior angles. Of what polygon it is, whether it's regular or however many sides it has, doesn't matter. But if it is a regular polygon, then each exterior angle is 160 divided by 10. So here is what I'm calling A in that picture. And this guy is what I'm calling B. And then, of course, there's one more relationship that's worth noting here. A plus B is 180 degrees. You get from a straight angle pair. Okay, so that's a quick overview of things we've done in the past. Let's now jump into the notes page. All right, so let's get after it here on page 1 of the notes. You'll notice that I've, for your benefit, I've copied up here at the top of the page all of the formulas that I just mentioned to you. So they're up there just as a convenient reference for you. Let's jump into this first problem. Working with regular polygons, please remember that means congruent sides and congruent angles. I repeat that because for two reasons. Number one is it's very important for you to remember what that definition is, because regular polygons have a lot of special features. And I also report it because it's something that students often forget. Okay, so question 1. If you know the number of sides of a regular polygon, how can you find the measure of an interior angle? Find the measurements of an interior angle of a regular 15-gon. So for this question, we need this formula right here. So the measurement of an interior angle for n equals 15, 180 times 15 minus 2 divided by 15, and that gives us an answer of 156 degrees. So again, let's see, what did we have to know? We had to know the number of sides, we had to know that it was a regular polygon, and then boom, we can use that formula to find the measure of each interior angle. Part B, if you know the number of sides of a regular polygon, how can you find the measure of an exterior angle directly? Find the measurements of an exterior angle of a regular 10-gon. So we have n equals 10, it's regular, so all the interior angles are the same, all the sides are the same. And this time we're going to use this formula. Okay, so the sum of all exterior angles is 360. If we want to know the measure of one of them, we're going to take that 360 degrees and then divide by n. So that gives us 36 degrees for each exterior angle of a regular 10-gon. All right, we're cooking with gas now. Let's jump down to part C. What if you know that the measure of an interior angle of regular polygon is 162? How many sides must the polygon have? Show your work. Okay, so let's see. I know that the measure of an interior angle of a regular polygon is 162. How many sides must it have? I'm going to go back and I'm going to use this formula again. But this time the unknown is n. So I'm going to say, let me go ahead and copy that down for us again. So we have 162 is equal to 180 times n minus 2 over n. And we have to solve that for n. It looks trickier than it actually is. Let's start by multiplying both sides by n. That gives me 162n on the left. The n's cancel here, so I have 180 times n minus 2 here. Let's distribute. 180 times 2 is 360. Let's go ahead and do a little bit of algebra. Let's add 360 to both sides. Subtract 162n from both sides. And I have 360 equals 18n. Divide both sides by 18. And I get n equals 20. So we just found out how to determine the number of sides in a regular polygon if we're told what the measure of each interior angle is. Okay, last part here, D. If the measure of an exterior angle of a regular polygon is 15 degrees, how many sides does it have? Okay, so let's see. We just used this formula right up here that said the measure of an exterior angle of a regular polygon is 360 divided by n. Let's try that again. So now let's plug in what we know. We have a measure of the exterior angle. We're told that that's 15 degrees. So that's going to be 360 degrees over n. Well, let's see here. We can multiply both sides by n, then divide by 15. Another way to think of this is we can just kind of write this out as a proportion and swap the 15 and the n. And that's going to give us n equals 360 degrees over 15 degrees. That's also known as 24. So there's actually two questions in this one. I answered the question of how many sides does it have, but I still have to answer what is the measure of an interior angle. So let's take a look at that, the measure of an interior angle. Well, we have a formula for that. It's 180 times n minus 2 divided by n. And that gives me 165 degrees. Okay, let's move on. Next question, 8-37. Suppose a regular polygon has an interior angle measuring 120 degrees. So we got a regular polygon, interior angle is 120 degrees. Find the number of sides using two different strategies. Show all your work. Which strategy was the most efficient? All right, so I'm actually gonna scroll down a little bit here, and I'm just gonna kind of draw a picture. So we have an interior angle that's 120 degrees. And I'm gonna like chop off the rest of the polygon. I do have also an exterior angle here. Let's see, 180 minus 120, this guy here has to be 60. So I'm just gonna kind of draw that picture and work from that. I know it's a regular polygon, so maybe I should mark that these sides are congruent, even though I can't see the rest of the picture. Okay, so two different methods. The first method I'm going to use is this. I'm going to say the measure of an interior angle is equal to 180 times n minus 2 divided by n. If you remember in the last lesson, I actually showed another form of this. I did some algebra to distribute the 180 and then divide out by n, and it looked like this. Okay, so I'm going to go ahead and use that form for this problem just so you can see another example. So I have the interior angle, it's 120 degrees. I'm not plugging in what I know. 120 degrees equals 180 degrees minus 360 degrees over n. Let's go ahead and subtract 180 from both sides. That gives me negative 60 degrees equals negative 360 over n. Well, I can just kind of swap the diagonals. That's that trick that I did in that last problem. and that's going to give me n equals negative 360 over negative 60, or n equals 6. Okay, that's one strategy. I am going to show you another strategy now, and this time I'm going to focus on the fact that the exterior angle is 60 degrees. Well, if we know the exterior angle is 60 degrees, and again, I'm just going to show you how I figured that out. That's not tough. It's 180 minus the measure of the interior angle, which was 180 minus 120, or 60 degrees. So if I know that, we also had this formula. For a regular polygon, the measure of the exterior angle is going to be 360 divided by n, because all the exterior angles are the same, and we know they have to add up to 360. So if we want to know one of them, do 360 divided by n. So if I have that 60 degree angle, and then I have this 360 over n, again, strategy, we can swap the diagonals here. And I have n over 1 equals 360 degrees divided by 60 degrees, and we get the same answer. There are other strategies as well, but they're all variations on the same thing. What we're asked to do now is answer the question, which strategy was the most efficient? That's really up to you to decide. I kind of think this one is most efficient. It looks like less steps here, but that's really a matter of personal taste and preference. It's up to you. Okay, that's it for page 1. Let's dive into page 2 now.